Yes, good evening, everyone. Am I audible? Am I audible? Okay, thank you, Bowman. So, first, I want to ask whether you have got the link of PPT or not. I have uploaded all the PPTs in that drive, and you can download all the subjects PPT. It is in zipped file. Okay, so you have to unzip first. So, you will get all the PPTs of all subjects separately. So have you all got the link has been shared on your WhatsApp group? Please reply. Okay. Have you downloaded or not? Are you able to download? Okay. I wanted to actually confirm whether you are able to download or not. Sometimes we share something with anyone and it is not accessible. Okay. So we need to give the access again. Okay. If you have downloaded means access has been given properly. I'm not sure about MCQs. Whatever I can do, I have done. Okay. Okay. So let's start the session now, right? Because we have something left. So we were discussing about the transducer, right? So what is transducer? What is transducer? So transducer is nothing but the devices which are used to convert one form of energy into another, right? Into another means like I am saying something, I have given the example. It is very easy example that we can remember also that whenever I am saying something, so it is the sound energy and the signal which is received by you is not direct communication. It is not sent through direct communication, right? So it was processed, then sent to you, and it was reconverted into sound. Okay, so sound to electrical, electrical to sound. So these two processes were done by transducer. So at transmitter side means at my side, I am using microphone. Okay, so microphone is a transducer which is converting my voice or sound into electrical form, and this wire is used to carry that electrical signal. Okay, and it will be given to the processor, whatever the processor we are using, and finally transmit, and it will be received by you. And what do you want? You want the sound to listen. Okay, so receiver, at receiver side we are using speaker. So speaker is used to listen. Okay, whatever I am saying you can listen if the signal is again converted into sound. So for these purposes we are using transducer. Okay, so we discussed about what is transducer introduction and what are the advantages and applications. Now we have the parts of transducer. Means what are the parts of transducer? What is there inside the transducer? Okay, so obviously this is transducer, so transduction element should be there. Okay, so this is the transduction element. Before that, we have to sense. Huh. Okay, sense means this microphone is sensing. If I am not saying anything, it will sense nothing. Means it will not convert anything. Okay. So inside the microphone, actually microphone is working on the principle of our ears. Okay. Whatever the principle means how the ears are working, depending upon that process, the microphone was developed. Okay. So it is sensing element. So first it will sense whatever the frequency, whatever the amplitude of the parameters there. So accordingly it will sense the signal, means the sound. Okay, and finally it will be converted. So converting element is actually the transduction element. Okay, so transducer is actually the converter. So this, so transduction element is basically the converting element. So finally it will convert into electrical form. Okay, and sensing element is actually what it is sensing. It is sensing the sound or your voice, right? So these are the two parts of transducer. So if we talk about the block diagram, so this is the block diagram in which we have used microphone. Okay, this is the loudspeaker. So microphone is this. This is actually the sound. Okay, it is applied or it is falling on the microphone. This is the symbol of microphone. This is the symbol. Okay, it is a symbol. Okay, this is the symbol of diode. Similarly, this is the symbol of microphone. Okay, so if it is shown in any of the circuit, you can understand that microphone is used there. Okay, so this device is actually the input device because we are giving the signal to this device. So it is input device, and after that it will be converted into electrical electrical form. Okay, and this electrical form is applied to amplifier. Okay, amplifier. So this amplifier will amplify the signal according to which the signal should be amplified first and sent to the loudspeaker. So whenever we use loudspeaker, so it is we are not connecting the microphone directly with the speaker. Between both of the devices we are using amplifier. Okay, this is a simple system. It is known as PA system. PA system. PA system means public address system, right? Public address. This is the system which is used to address the crowd, the public. Okay, so this is PA system in which we are using three devices: microphone, amplifier, and speaker. Okay, so this is the symbol of a speaker. So this is again sound. So we applied sound as input and we are getting sound as output, right? Between this, we have processed the signal and signal was in form of electrical and it was done by transducer, right? So have you understood what is input transducer, what is output? Input means whenever we generate any signal in any form, it will be applied to input transducer. It will be converted into electrical and processed. And finally, the signal which was in actual form should be reconverted into actual form here, like sound. So this is the speaker here, or loudspeaker, right? Speaker or loudspeaker both are same thing. So this is the output transducer. Any doubt to anyone of you? You can ask me. Okay, it's very basic diagram. You can think of it. Okay. So what are the applications? So as we have understood that transducer are firstly used to convert any form. So whenever we measure anything, right? So if you are having any engine, so what is the load on engine? Because if we use any engine like generator, for example, so generator is of, for example, 4 kilowatt, right? 5 kilowatt or 4 kilowatt. 5 kilowatt is there actually. So we cannot give more than 4 kilowatt load or 4.5 maximum. Okay, because after this load means if we are applying more than this load on generator, it will not work properly, and there may be failure of the system. Okay, so we have to see the load continuously, whatever the load is there on the engine. So transducer is actually sensing the load and showing through the meter. Because we cannot understand whatever the load is there, so we can see on in the meter what is the speed of your car or bike. How can you get that? Through the meter. Okay, so we have the meters to measure or to see the load on the engine. They are used to detect the movement of the muscles. If muscle is moving, okay, so what is the movement in the muscle? So it can be processed, and it is done by acceleromyograph. Okay, so this is used to get the movement in the muscle, whether the movement is there in the muscle or not. If there is the movement, then how much? Okay, so we can see that. Transducer use an ultrasound machine. Okay, ultrasound machine means, do you know ultrasound? Scanning, we can say. Okay, sonography. Nowadays we are using sonography. So what is the use of sonography? To detect any problem inside our, suppose, stomach or anywhere, right? So it sends the rays and form, get back the signal, and it is shown on the screen. Okay, so to convert those waves into the picture. Okay, so we are also using transducer. Is It is used to, like we have used in PA system. Okay, it is used in a speaker, that is actually converting electrical signal into acoustic sound. This is the example of this thing. Okay, so this is about this diagram. And the antenna is also the transducer. What is the use of antenna? Antenna is used as transmitter as well as receiver, both sides. At transmitter side, it is transmitting into air. At receiver side, it is receiving from the air, right? So in air, it is in form of EM waves, electromagnetic waves. It I told you in the beginning, right? So it is in EM form. So first, it will convert. Transmitting antenna will convert into EM waves, and this RX antenna will convert EM into electrical form again. So what is this? This is the transducer. First is converting electrical into EM, and second, that is receiver side, is converting EM into electrical. Okay, so EM waves into electrical signal. Who is converting? Antenna. Okay, so antenna is again the transducer, which is used to convert either electrical to EM or EM to electrical. So these are the examples or applications of the uses of transducer. Where do we use that? Now we have another type of transducer, that is thermocouple. So I told you in the introduction part that thermocouple is used to sense the temperature. Okay. So one of the best example is an AC or refrigerator, right? Refrigerator means fridge, right? It is not fridge actually. It is refrigerator. है ना? Refrigeration process is there. Fridge means to freeze, right? To make ice, right? So it is not fridge actually, but we use fridge as a common word. Okay. So thermocouple is used there. Why? Because we want to see there is compressor. There is compressor in refrigerator, right? Fridge, or in AC also. So you can experience the starting of the compressor. Sometimes it starts, sometimes it stops, right? So on which basis it starts or stops? So this is the thermocouple, because if we have set the temperature at 19, okay, right? So if it is more than 19, the compressor will automatically be started. How? Who will inform the compressor that you should start? thermocouple. So it will continuously sense the temperature because we have set the temperature at 19. So if it becomes more than 19, the compressor will be started and it will start to maintain the temperature again at 19. So thermocouple is the transducer which is converting the temperature into electrical form. Why electrical? Because compressor will be started through electrical signal. Electrical form should be given to it. So it will convert into electrical. So this is the transducer. Okay. It is very simple, robust, and cost effective. It is not too much costly. So it is very cheap, right? And used in wide range like temperature measurement process. Wherever we want to uh, means monitor the temperature, we can use this. Okay. And this is the common statement thermocouple, right? This is the diagram. How does it work? Means there are two wires of different material, wire type A, wire type B. So there are two junctions. One is hot junction, second is cold junction. Okay. So it is this point is continuously sensing the temperature. Okay. And this is continuously sensing the cold temperature. Means suppose 19. The temperature is suppose 29 degrees centigrade, right? And we want to maintain it at 19. Okay. So this is 29. This is at 19. Okay. So we have to convert this 29 or we have to shift, we have to maintain from 29 to 19. But whether it is done or not, it will be shown here. So it is in millivolts because very less voltage will be there. Okay. So that is why this is in millivolt. Whenever we see the value in that meter, it will be in millivolts. Okay. Right. So this is the basic diagram of that. So these are the principle of operation that how it is working or with means using which material we are using. So this is using two dissimilar metals. As I told you here that wire type A, wire type B. So these wires will not be of same metal. Okay, so it will be dissimilar. It will not be similar. Okay, and this will means it is actually making a magnetic field because whenever we use dissimilar metal, then there will be thermomagnetism there. Means magnetic field will be experienced. Okay, and it was observed due to thermoelectric current because whenever the temperature is there, accordingly it will be converted into electrical form. So whenever temperature is converted into electrical form, so it is known as thermoelectric current. And if current is flowing, so some magnetic field will also be developed. Okay, so that is known as thermomagnetism, right? Clear? And magnitude of voltage, whatever the voltage will be shown there in meter, it is depending upon the type of wire being used, means which material we are using there. Depending upon that, the magnitude may be varied. Right? Suppose I have one type of thermocouple, or any other person has different. Okay, so there may be difference. Why? Because the metal which we are using as wires may be different. So due to which it may be it change or they may be vary in the value. Okay, and voltage is in millivolt. I already told you. Okay, and the little current because the current which is because why millivolt means the current is very less, that is why voltage because V is equal to IR. So if it is in millivolt, so then you can understand what will be the value of the current. So it is also little, it is very less value. Okay, and The power can be generated by single thermocouple junction. And if we are using many, means more than one thermocouple in series, then it will be known as thermopile. Series thermocouple, sorry, thermocouple is known as thermopile, right? So thermopile is the series combination of thermocouples. Means if we are using more than one thermocouple, two, three, four, five, and connected in series, then it will be known as thermopile. So this is the principal operation. This was the hot junction. It was the cold junction, and here we have used the millivoltmeter, right? So what is this? So this is the desired temperature T sense is obtained using three inputs. First is at, means this is ET, it is the characteristic function of thermocouple, and the measured voltage, that is V, that is this, and reference junction temperature, that is T reference, that is this. Okay. So this T sense is obtained using three, that is the function of thermocouple, voltage, and the reference temperature, that is T reference. Okay. So it is shown as ET sense, that is the this, is equal to voltage, that is this voltmeter, and ET reference, that is at. So this is equal to this plus this. You can write it. Okay. So this is the equation, that this is equal to this plus this is the equation of thermocouple. So depending upon the operation, we can write the equation also. And these are the application. As I already told you that these are used for larger temperature range, okay, up to 3000 degrees centigrade. And application may be kilns, that is, do you know kilns? Can anyone tell me kilns? Just a minute. What is this? Can anyone tell me? Nobody? Kilns is a large size oven. Yeah, bhatti, yes. I mean, this is the bhatti, right? This is the big bhatti that is used to bake bricks, okay, or clay or any other thing. Like uh, we want to bake anything. So best example is the means brick manufacturing, right? So there is a big bhatti. Inside that we fill with the raw bricks. Raw means the clay, the soil bricks, right? And after some time, I think 10 or 20, whatever the time, I don't know. So after that, we will get the final or fine bricks, that is in red or orange color, right? So it is the baked one. Okay. So that is the big oven that is to bake bricks. Okay. So but he is there. Meenal is saying correct. The best answer. Okay. Gas turbine. Okay. Gas turbine, diesel engines. Okay. So anywhere, wherever we want to monitor the temperature variation continuously, because in kilns we want to see what the temperature inside that, because if the temperature is less, then it will take more time. So we have to monitor continuously the diesel engine, as well as whenever you drive the car, you continuously see the temperature, because if temperature is not shown there, sometimes the engine becomes hot because you are driving continuously for 500 kilometers. That is why it is suggested that please stop your car after 200 or 250 kilometers or 150 kilometers, because after means taking the rest will be for you as well as the car or vehicle, right? So that engine becomes cool, right? So we have to continuously monitor the temperature whenever you drive the car, right? Especially for diesel engine, because it becomes hot very fast. Okay. And in industrial process, because in industry we have so many steps they are processing, and sometimes you means you might have heard about that there was blast in that factory. Okay. So that blast is due to the temperature. Sometimes more time it is due to temperature, because uh, the we are not monitoring that. Okay. If it is getting more temperature, then there may be blast, right? And there may be accident, a big accident there. Okay. Fog machine, any machine, wherever we want to see the temperature, we can use that. They are less suited for smaller temperature difference, because if temperature is very less or difference is very less, then it is no there is no need to use that. Okay. So it is mostly used for higher temperature, right? Any problem up to this point? Okay. The next detector we have, this is the resistance temperature detector. It is short, in short, it is RTD. Resistance temperature detector means we have to detect the temperature. So best example is of PUC, the pollution that we get checked at the means the vehicle. PUC vehicle is there on the roadside, right? So what do we do? We go to the PUC van or car. It is known as the PUC van, right? And what do we want? We want the certificate. We want the certificate. So it gives us the whether it is perfect or not, your car is working proper or not. So they give the PUC certificate accordingly. So what device they are using? They are using RTD. So you can see this one. That is why I have used this diagram so that you can recognize very easily. Okay. So what is there? So this is this actually. There is sensing element at the top, right? So whenever we insert this device, then it will sense the temperature, what the temperature is there at the output, right? And this is the insulation actually, and this is insulated lead. And this, after the sensing, it would be converted into electrical, because the signal which is given to the system should be converted to electrical form. So this is the basic sensing element that is inserted in that pipe, hose pipe, and it will give the temperature, whatever the temperature value is there. Accordingly, it will give the signal to the system, and accordingly, it will give the value, whatever the value of the means engine is there of your car. Then we can get it printed in printed form, and that is known as the certificate. Okay, so this is basically a temperature sensor. Okay, and operate on the principle of change in electrical resistance of metal with change in temperature. So what is being done there? Whenever the temperature is changing, accordingly there will be change in the resistance of metal, right? The metal that we are using there, that resistance will be changed according to the change in the temperature. That is why the name is resistance temperature detector. So due to temperature, the resistance of the metal that we are using will be varied. Accordingly, we will get the values. The metal that we are mostly using are platinum, nickel, or copper. Okay, so these are the three metals that we generally use for RTD. Why? Because these are giving us the accurate values. Accurate because if we are using the metal that is not providing the accurate value, then if we are getting the certificate at that van, it will be this, it will another, it will be different. So it should not be there. The variation, some very little variation is acceptable. But if there is great difference, then it is not acceptable. So these metals are giving us accurate value. So these are highly accurate and reliable over a wide temperature range. Because if the car is means giving high temperature, the engine is generating high temperature, then it should give us that value also. Okay, so it is giving us wide range. Why I'm using the word car? Because we can connect that with that example. Okay, you can understand how does it work, right? It is not used in car only. It is used at other applications also because it is used in industries also, in scientific application. Okay, for for experiments, right? Got it? This is the characteristics between resistance and temperature. Okay, so you can see that we have these three metals, and these are the characteristics between temperature and R resistance. Okay, so you can see that every metal has different resistance value because whenever the temperature is varying, the resistance will also be varying. Okay, with respect to the variation in temperature. So if it is continuously increasing, then the resistance will vary, and if resistance is varied, accordingly we will get the varied values. Okay, and this characteristic is drawn between resistance and temperature. That is why it is resistance temperature characteristics. So characteristics is nothing but the graph between two parameters, and we have two parameters, that is temperature and resistance. Why? Because the resistance variation is dependent upon the variation in the temperature, right? The temperature range for platinum is 650, while for copper and nickel is only 120 and 300, right? So this is the range up to which it can detect the temperature. So if we are using platinum, then it can detect up to 650 degrees Celsius. But if we want to detect very less temperature, that is 300 or 120, whatever, then we can use the metal accordingly. So depending upon the application where you want to use, right? Suppose you want to drive for 20 kilometers daily, then why should we spend 2 lakh rupees, right? So accordingly, we should opt the vehicle depending upon the requirement. So similarly, if we don't want to detect more than 300, then why we should use platinum, right? These are the modules of RTD, means in which modules we generally use RTD. So this is the two-wired RTD. In two wire means one and two. So this is the bridge, right? And this is RTD that we have connected here. The device is connected here only. Okay. In three wire means this is actually one. You can understand this is one wire. This is two, right? This is two actually. It is connected here, so it has become one actually. After that, in place of connecting here, we have extended this here. We have extended this wire. It is not connected or means mingled here. This is the different wire, the same wire, this, but these wire are now separated. it has become 2. So 2 plus 1, 3 wire. So this is 3 wire. So what is the advantage? That is, because there was one wire up to this point, this was one wire. Now we have two wires, so this wire is extended, and due to extension, the variation will also be there. So extension wire resistance is important to be considered. So we can use the more variation range using three wire. And if we use 4, then it will be improved. So it can use for 10, and this can use for 15 ohm. Okay, variation. This is the variation actually. So it is increased using 4, right? So we use 3, either 2, 3 or 4 wire RTD bridge. If we want to improve more, accordingly we can use any one of the modules. Any doubt? Okay. Meenal, have you got the PPT? Math की PPT नहीं मिली. Okay, let me check. Once I get, I will upload in the same drive. Okay, you can drive from there only. Okay, because I have shared the drive link. So whatever I upload there, it will be visible to you. Okay, so I need not to means share again. Okay, okay. The next is the strain gauges. Do you know strain? What is strain? Strain and stress. Hmm? What is strain? So Sanjit, you have got mail also? Okay, because I told them to send by both modes, right? That is WhatsApp group as well as mail. WhatsApp is easily accessible. That is why I shared through that also. Certain people, the people. Actually, Ria, there will be merging of the units, okay? Because there are 12 sessions, so it is not separated that 12, 13, 14, okay? So faculty has merged some of the units, right? Okay. So you need to verify the unit from syllabus and SLMs. Okay. Okay, Ria. Okay. So you can understand that is the enlargement and stress is the compression. Okay. So if we compress something, there will be stress. If we stretch something, that is stretch. Okay. Stretch means if we are expanding anything. Okay. So it is enlargement. So this is strain. If something is compressing, then it is stressing. Okay. So strain gauge is actually measuring the enlargement of the material, the wire that we are using. Okay. So we are using the resistive foils. Okay. There's the metal wire. This is a metal wire. This is gauge backing, right? It is a cover. You can say there will be gaps between that we have put the wire or metal wire, and it is foiled, and this is the shoulder pads where we have connected two leads. Okay, so these leads will be connected with the system that we want to connect. Okay, so it is made of long thin piece of metal conductor. Metal conductor means the wire. Okay, foiled bonded to be flexible backing material known as carrier. So this is the carrier actually. This is carrier. Okay, there will be gaps according to the shape. So we have put the wire. We have fixed the wire inside those gaps and made the strain gauge so that the wire uh, cannot touch each other. Okay, so you can see here there's gap. There's gap between two wires. These are not connecting or touching anywhere. So these are two leads, electrical wire leads. So we can connect wherever we want to use. I will show you in the next diagram where we are using it. Okay. So it is actually a sensor. And what it is sensing? It is sensing the force like pressure, tension, weight, anything. Okay. So whatever we have types of forces, we can we can sense using strain gauge. And after sensing those forces, it will convert that into electrical resistance because whenever there will be compression or enlargement on the material, there will be variation in the electrical resistance. Means electrical resistance will be varied depending upon the force that we are applying on it. Okay, and that resistance of strain gauge vary with applied force. That is, I already told. And stress and strain happen when outside force are applied to a stationary item. So whenever we apply the force on any of the object or any stationary item, then there will be stress or strain happen on that material. Okay, means there will be variation in resistance, and we will convert that into electrical power, right? So it is working on the principle electrical conductance and it's dependent on conductor geometry. So what type of conductor we are using? Okay, the electrical resistance of every material is different. Okay, so depending upon the requirement, we use the metal, and the conductor is stressed within the limit of its electricity. Right? Elasticity is, suppose we are stretching something, and after that condition, that may be broken. Okay, so we have to take care of this also. That this is the limitation of its elasticity, right? So elastic, we use elastic, right? So elasticity is the quality of that material. Okay, so if we are continuously stretching, it should not be broken. Okay, so it will not break. Okay, but maybe narrower or longer. So whenever we are stretching, so it will be narrower and longer. And if we are compressing, then it will be less of less strength but wider. Okay, so depending upon stress or stress, it will change its shape. So you can see here, it will be shorter and broader if we compress. Okay, and ultimately it changes its size. So depending upon the force, it will change its resistance. Where do we use, right? So we can use it on the basis of the application like airplane. So there are wings. So whenever it is flying in the air, there will be continuously force upon that. Okay. So what force it can bear, what force it is experiencing, we have to continuously monitor it. Okay. Cable bridge, you might have seen the bridges having cable. In Bombay, we have, right? So that cable bridge should continuously measure the force because depending upon the person or car or the crowd, it will there will be strain. Okay, it will be stretch, right? And if it is continuously, if we are continuously increasing the force, it will be stretched more and more, and at after some time it can be broken. So we want to monitor it whether the more crowd can be bared by the bridge or not. Okay. So deformation, what type of deformation is there? We have to take care of it to avoid the accident. Rail monitoring. If train is moving on the rail, rail means the puttery on which the train is moving. Okay. So rail monitoring is we have to continuously monitor the rail because whenever the train is moving through that, then there may be expansion. Okay. So expansion is proper or not? There should not be more expansion. Okay. So it should be monitored. But there are some limitation also because if we are using anything, then there will be limitations also. So this works in one direction. Means single strain gauge is often referred to as axial gauge, which is short for uniaxial gauge. Means whenever we have large application, means in more direction it is expanding, then strain gauge will not work properly. Okay. If temperature is more, then resistance will also be more. In that case, it is also not possible to use. Okay. And it can be resolved by using strain gauge that are self temperature compensated or by dummy strain gauge technique. Means we should use the strain gauge in two dimensions, right? Or multi-dimensional so that we can monitor any of the directions like this, like x-axis we are using or y-axis we are using, right? So we can use that. Similarly, we have load cells. What is load cell? It is converting the force like tension, compression, pressure, or torque, whatever, into electrical form so that we can measure it and standardize it. Measure it means we want to see what the force is there. Okay, so it is actually a forced transducer. It is force transducer because all the forces which we are applying on them, it will be converted into electrical force, right? So if force, if applied force is increasing, then we have to monitor that. So the force applied should be monitored using load cell. Okay, right? So if it is continuously increasing, then electrical signal will also change in same proportionate, right? It will change proportionally according to the force. So you can see this diagram. Okay. Last, you can see the most common type of load cell are pneumatic, hydraulic, and strain gauge. Pneumatic means air based, right? Hydraulic means hydraulic means what is it? Liquid. Okay. So air based or liquid, right? So depending upon the usage, we can use that. Okay. So this is the normal load cell. After putting this weight upon that, it was it was normal. After that, it has become like this. Okay. So it was pressed. Okay. So it is there's compression. There was no deformation at that time. After compression, this elongation means the change like this. This is mounted at the wherever we want to mount, and there's narrow geometry concentration, the strain here. So you can observe these things when the weight is put on it. The force is applied. Weight is force. So this force is applied on that. Accordingly, there will be expansion, there will be elongation in the metal, and compression can be seen there. So depending upon weight, it will be compressed more and more. Got it? So these are all about that same thing that I have explained. Okay, so no need. You can see here. So we are using strain gauge here, right? So whenever we are using the strain gauge here, so depending upon the force, right? This strain gauge will give the value. Okay, it will also stretch. It will also stretch. So we can measure it. We can see this. So this is used. We have used the bridge. This is known as Wheatstone bridge. Wheatstone bridge is having four resistances. Okay, R1, R2, R3, and R4. So it should be, if there is no change, there is no variation, then it is known as balanced balanced bridge, and the condition is that R1 upon R2, this resistance upon this, should be equal to R4 upon R3. So this is the balanced condition. So whenever there is variation, this resistance will be varied. There will be resistance in the metal. Okay, so depending upon that, it will be measured here. Okay, so common type of load cells are pneumatic, that is air based, hydraulic, that is liquid, vibrating. Vibrating means vibration is there, it will be measured. And piezoelectric. Piezoelectric effect is actually whenever there's, I am giving you one example. This is the quartz crystal. Do you know quartz? You all have a watch, okay, clock basically, clock at your wall. So there is written quartz, QUARTZ. Have you ever seen quartz at the mid of the clock? You can see. If you have not seen, see today. Okay. So whenever you purchase any clock and put it on or hang on a wall, then there is printed quartz at the mid. Suppose this is the clock like this. It will be printed here. Quartz. So what is quartz? Quartz is a material. Material means there will be two plates. Okay. I'm just explaining to make you understand what is piezoelectric. Okay. So this is quartz. We have connected two plates here. So what is the use? Why we are using quartz? So there is second needle. Okay. Tick, tick, tick. Okay. So that second needle moves continuously, right? And why it is ticking like this? Tick, tick. So this is the frequency actually. Who is giving this frequency? The the cell. So this is the cell. So if there is no cell, it will not work. So once you insert the cell, you connect the cell, this tick tick needle starts working. Okay. So why? Because whenever the cell is connected here, this plate will provide the voltage, and depending upon the voltage, it vibrates. It vibrates, and this vibration is applied to that second needle. Okay, so depending on tick 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 tick, so this is the vibration. Okay, so this is the piezoelectric effect. So whenever we apply any force on the quartz crystal, this is quartz crystal. Okay, it vibrates. Okay, and this effect is known as piezoelectric. So this load is also working on piezoelectric effect. So it is known as piezoelectric load cell. Got it? Piezoelectric. Ria, I need to means ask to the higher authorities about the question bank. Okay. Whatever is in my hand, I have done. I have shared all the PPTs. I have to check for mathematics only. Okay. Mhm. I already told to the LMS team, right? Meenal. So any doubt in this topic? So where do we use load cell? Load cell basically used for measuring the forces. Okay. So it is used in laboratory for balances. Balance means weight, industry scales, platform scales, and universal testing wherever the testing machine is there to convert any load into electrical, then we can use it. In 93, British Antarctic Survey installed load cell in glass fiber nest to weigh albatross chicks. It is chick means it is a bird. So they want to weigh for that bird. This bird is having large fins, that is wings, that is around 8 feet, 8 feet, I think so, 6 to 8 feet. So they want to weigh that chick also. So they use the load cell only for that purpose. And load cell also used for seven post shaker, that is for race car. It is used in race car actually. So they want to see the load, what load it can bear, what maximum load it can bear. So it is also used for this purpose. So this is the application of that. So we have understood all the transducer, what is transducer, what type of transducers are there, what are the applications, what is the principles of each and every transducer. We have understood, we have discussed about thermocouple, RTD, load cells, each and everything. So this was your last unit, and one thing that Meenal was telling, that RC filter. So RC filter is not in your syllabus, Meenal. That is why I skipped, I think, right? LC was done. And one thing, that is Zener, and you were talking about Zener and photovoltaic cell. So I can start that only. So let me start first. Just a minute. Wheatstone bridge is not transducer. Wheatstone bridge is the process that we are using for balancing. Okay. Okay, Ria. Thank you so much. It is not load cell. We are using, actually, it was the use of means that was strain gauge. We were using strain gauge in the Wheatstone bridge and making a load cell. Okay, because strain gauge was used with the load cell, right? So that is the actually application, and bridge was using for making the balance form. I also wrote the balancing condition R1 upon R2 is equal to R4 upon R3, right? So that is the condition that will show you whether it is balanced or not. Okay? Okay. Let me share the window. So this is the Zener diode that we were just, actually we have studied PN junction diode, PN junction diode. So whenever we say diode only, So it is PN junction. But Zener diode is different type of diode that is having P and N type material, right? But the impurity which was doped in PN junction and Zener diode is different. So it is specially designed diode, okay? And the difference is that this PN junction works in forward bias, right? This junction should be forward biased. This is P, this is N. So it should be connected like this. Then it will be, because positive is connected with P, negative is connected with N. So this is forward biased. So this PN junction diode will work in case of forward bias only. But this diode works in reverse bias. Okay, reverse bias. And the difference in structure, in PN junction, we draw like this only. But here we will make this bar as Z, like this. Okay. So this is normal, that is PN. This is Zener. Got it? So this is anode, which is this one. This is cathode. This is this one. So same thing is there in PN junction also. And this is the characteristics. So in PN junction, the characteristic was we are continuously increasing the voltage. This is the current. This is forward bias characteristic. In reverse bias, we are continuously increasing the voltage, right? That is negative, but the current was very less. But after reaching at high voltage, the junction was broken, and that is known as avalanche breakdown. So this voltage is known as breakdown voltage VB. So this is higher voltage value. But in Zener diode, this voltage is very less. So at less voltage, at less applied voltage, this junction will be broken, and this is known as Zener breakdown because this is Zener diode characteristic. So the advantage of Zener diode is that we can use in very less voltage. We need to apply very less voltage for the conduction. Okay. In forward bias case, it will work as p-n junction. It is work as p-n junction, but in reverse bias, we need to apply very less. Getting this or not? In forward bias, p-n junction and Zener are same. It will work like p-n junction diode. But in reverse bias, this p-n junction will start conduction at very high voltage, but Zener diode will start conduction in very less value. Right? Any doubt? This is the circuit diagram that we are using. So this is the fluctuating DC. Okay. So this is basically the regulation. Do you know regulation? Regulator we use at our home. Fan regulator. What is that? If we fix at 2, then it moves at that speed. If we move to 3, it moves with higher speed, but with constant speed. Why speed is constant? Because we are providing the constant voltage. Okay. If we vary the voltage, the speed will be varied. It will be changed. Sometimes it is less, it is high. Okay. But we want a constant speed. So this is known as regulation. So this is used as regulator. Okay. It is used as regulator. So this is the fluctuating. Fluctuating means varying, the changing value input. And we have used Zener here. But after applying to the zener, this is the load resistance. So if we measure the voltage, this we will have, it is wrong spelling, constant constant voltage. Okay. So this is the application of Zener, that if we use Zener diode in the circuit in place of PN junction, then it will be used as regulator and provide the regulated voltage. It is known as regulated regulated voltage, right? Any doubt to anyone? It regulates voltage, right? Regulate means changing thing. Regulate means fixes, constant, make constant value. Okay. It regulates the varying voltage, and regulates means the constant voltage. Got it? Photovoltaic cell is again the diode, but depending upon the photo. What is photo? What is photo? Fluctuating matlab changing. Yes. Yes, Meenal, fluctuating means varying, changing. Actually, you should know the difference between varying and changing. Changing means it is permanently changed, permanently converted from higher to lower value, lower to higher, then it will not be changed. Varying means sometimes it increases, sometimes it decreases. So this is known as variation. Okay. So variation and changing is different. Okay. Got it? Okay. So this type of diode is depending upon the photo, and photo is the light, right? And it is depending upon the packet of light, and packet of light is known as photon, right? So you can see here that this is the sunlight, this is sunlight, and it is falling on this surface, and this surface is having front contact, it is metal, and this is back contact, this is also metal. So whenever the light falls on this material, okay, so this material is the semiconductor material. Okay, it is anti-reflective coating because it is why it is anti-reflecting, because if reflection is there, then whenever the light is falling on that, it will be reflected back. Okay, so it should be absorbed at the same time. Okay, not not very less or whatever the value, it should not be reflected. So whatever the sunlight is falling on, it should be falling 100% or properly on the metal. Okay, so you can see that we have connected this bulb. So this is the positive, this is the negative. Okay, so once the light falls on it, this diode, this is working as diode. Okay, and you can see here also, so this is PN junction, and this is the falling of the light. So what is it is doing? So depending upon this light, right, this is providing the path, it is providing the current to this bulb. So whenever the sunlight is falling on it, this bulb will continuously glow. Otherwise, it will be not glowing, because whenever the light falls on it, the electron and holes will be produced. Okay, it will be produced. And if it is producing continuously, then the current will be flowing continuously in these wires, and the bulb will glow accordingly. So this is photovoltaic cell. So this is cell. This is cell. So this cell will provide the current when 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 light falls on it, right? So this on it, right? Any doubt to anyone? You can ask me any question, any doubt, because it's your last session. Yes, whatever the PPTs I have used is given to you. Okay. The question will come from your syllabus, right? So you are not in 8th, 9th, 10th or 12th class. Okay, the whatever the question we have provided you will be given as it is. Okay, you are in BCA now. You are becoming professional now after 2 years. Okay, 1 or 2 or 3 years. So the question may be any from your syllabus. Okay, we should be ready with the knowledge. Okay. So I hope you all have enjoyed all these sessions with me and understood whatever I taught you. So this is your last session and interaction with you, and hope you will enjoy your coming 2 3 years with us, and all the best for your examination and for 2 years examination. Whenever I have the time, I'll interact with you, right? So thank you so much. I also enjoyed with you because I also want the students so they can ask the questions. Thank you so much. Okay, Ria, I'll get it checked. Okay. Don't worry, I have provided you all the PPDs and SLMs. It is sufficient for you. Okay. So if you study from those only, you can fight the examination. Not fight actually, you can give the answers of all the questions. Okay. So download, it is suggested to all of you that download all the PPTs. Okay, as soon as possible. I'll not remove the access, but it is request to you, and I'll check about the mathematics and upload on the same drive. Not today, tomorrow or day after tomorrow. Okay, you check regularly and you will get it. Okay, so thank you so much. Happy learning. Thank you so much. All the best. So whenever you get the feedback link, you fill it so that I can improve myself whatever the mistakes I have done. Okay, because you can observe the problems, and I want the continuous improvement in myself so that I can give the better sessions to your juniors, coming juniors, and the instrument. Okay, thank you, bye bye, take care, thank you, happy learning. Thank you, Bhupen, thank you, Kushbu, bye.